Hello guys, Mr. Jenkins back again with another lesson from chapter 5. It is about dividing polynomials. So basically your learning target is that you can use either long division or synthetic division to divide polynomials, okay? So technically you kind of already know how to divide polynomials in a certain situation, like you know how to factor. That's dividing polynomials, but we can't always factor. Okay, so this is a kind of a clip from your book on just the process. And let me just say also, this lesson is kind of more of a procedural lesson versus really applying the stuff we're going to know. So you might not see the point in it initially, but this stuff will be used a lot for the rest of chapter 5, and even in previous lessons you could apply some of this stuff, and also in pre-calc. Okay, so stick with me. Maybe kind of a little bit of a boring lesson, but it's going to be stuff that can really help you on the test. All right, so long division is it's just kind of, we won't use it as much. You wouldn't really probably want to use long division unless you were specifically asked to show your work that way. All right, but anyways, here's how it looks. So it says divide 3x squared minus 29x plus 56 by x minus 7. Okay, so x minus 7, and we draw it out just like an old school long division box. All right, so what we want to look at first is kind of this first term, right? So 3, we want to multiply something times this to make it 3x squared. All right, so what we multiply by there would be 3x, right? 3x, because 3x times x is 3x squared. Okay, so now we do 3x times x is 3x squared, and 3x minus 7 is minus 21x. Okay, and now again, just like any old school division, you subtract there. Okay, so 3x squared minus 3x squared is 0. That's what you want to do, is eliminate that. And then you got negative 29x minus negative, so plus 21x. So that'd be minus 8x, or negative 8x. And we bring down the plus 56, and we basically repeat that process. All right, so now we're thinking, what do we need to multiply this by to make it equal to negative 8? All right, so the answer to that is negative 8. Okay, so now we multiply by negative 8. Negative 8 times x, negative 8x. Negative 8 times negative 7 would be plus 56. And then we subtract again. You probably already recognize those are exactly the same. So negative 8x plus 8x is 0. 56 minus 56 is 0. So in other words, what we just basically figured out is that x minus 7 goes into this quadratic trinomial evenly, right? Because if I multiply this times this, the result would be 3x squared minus 29x plus 56. All right, so hopefully that makes sense. So our answer, our quotient, is 3x minus 8. And then you might have to say with remainder 0. So that's going to be important too. We'll focus on that remainder kind of once we get going. All right, let me just show one more, because people struggle with this, and I'll tell you why they do. Not that it's overly difficult, but once you learn the next thing called synthetic division, you'll really not want to do long division, but you do kind of need to know it. So I'm going to show the other one. All right, so this time we're dividing x plus 3 into 2x cubed plus 3x squared plus x plus 6. So a little bit longer problem here. All right, so now we should get 3 terms, right? So if you think about the last problem. Okay, so x times what equals 2x cubed? That'd be times 2x squared, right? So we want to multiply by 2x squared to get started. So 2x squared times x, 2x cubed, which is what we wanted. And then 2x squared times 3 is plus 6x squared. Now we subtract. That minus that is 0. 3 minus 6 is negative 3, so we have negative 3x squared. Now we bring down the plus x. Okay, now our thought is x times what equals negative 3x squared, and that would be times negative 3x. Next is minus 3x. So negative 3x times x is negative 3x squared. Negative 3x times 3 is minus 9x. Now we subtract. Obviously those cancel. Then we have x, and that ends up being a plus 9. So 1 plus 9 is 10. So 10x. Bring down the plus 6. As you can see, this is very similar to regular long division, except, there are some obvious differences as well. All right, so now the question would be, what would we finish up our division problem with? In other words, what would go here? See if you guys are getting it. All right, hopefully what you came up with is plus 10, because 10 times x equals 10x. Now we just multiply. We get 10x, and then plus 30. So this time you might notice they don't match up exactly. In other words, we're going to have a remainder of 6 minus 30 is negative 24. All right, so our answer in this case contains a remainder. So we could say this 2 ways, okay? So we could say it's 2x squared minus 3x plus 10 with the remainder of negative 24. Or you can also write it this way. More of an algebraic kind of representation. You could go 2x squared minus 3x plus 10, and then it'd be minus 24 over x plus 3. So that's almost writing it like a mixed number kind of deal. Okay, so either way means the same thing. All right, so that's long division. And you may have a test question that asks you to do that. Okay. Synthetic division is so much easier to use, all right, but there are some things that you have to remember. There are some key things, and then it's just kind of memorizing the process. All right, so this one is synthetic division. It gives you a good list over here on the notes if you want to check that out, but I'm just going to go through how to do it for time purposes. All right, so what you divide by here is not actually the whole linear factor. You divide by the 0. All right, so if we set x plus 1 equal to 0, we would know that that 0 is negative 1. Okay, so we're dividing negative 1, and then we divide into the coefficients of our polynomial. So 1 x cubed, and then so we're going to do 1, 2, negative 5, and 6. So it looks like this. Negative 1 into, and then we just do the coefficients. 1, leave a space. 2, leave a space. Negative 5, leave a space, and negative 6. Right? Then you put a little line under there. Okay? So the first thing is where you have your blank space. Think about our long division. Okay, we started with a blank space, right? So you just bring down that term, okay? And now we start to multiply, all right? So we take -1 times whatever is down here, all right? -1 times what's down there is -1. Okay, now we're adding, all right? So we're not subtracting, we're adding. 2 plus -1 is 1. All right, so now we repeat. -1 times 1 is -1. Add these two together, you get -6. And multiply again. -1 times -6 is +6. We add, and we get that nice remainder of 0. Okay, so now we have to interpret what our answer is. The last one is always your remainder. So this is a constant. That's an x to the first. That's an x squared term. Okay, so now you got to be able to interpret your answer as these are the coefficients of what, right? So that's the coefficient of x squared. So it's 1x squared plus 1x minus 6 times x to the 0, or just -6, and then it has a remainder of 0. All right, so just some common mistakes there. A lot of people will divide by 1 because they see x plus 1, so they screwed up there. I see a lot of people do this as well. They'll do like something weird, like 2 minus -1 is 3, right? So you got to remember little stuff. So that's why we practice these things. All right, so let me do maybe one more. I'll leave the next one for you. So maybe go ahead and try that one. Might be a little bit tricky because we skipped the x squared term. But you can look at the notes for that. All right, so let me do one more. So if I'm dividing by x plus 6 and using synthetic division, then I want to actually divide by the 0, which is x equals -6. And now we're ready to go. So -6 divided into 1x cubed plus 5x squared minus 3x and minus 4. All right, so then we go ahead and just get started. First thing we do is bring down the 1. Now we start to multiply. All right, -6 times 1 is -6. Add those two terms together, we get -1. -6 times -1 is +6. -3 plus 6 is +3. -6 times 3 is -18. So we can see now we're not going to have that remainder of 0. So -4 plus -18 is going to be -22. Now, another potential mistake here is you might say, okay, that's the constant, so that's an x term, that's x squared, and so that's x cubed. Okay, here's a hint that that would be wrong. If we're dividing an x to the first into an x to the 3, our biggest term, it should go down by 1 degree, so that should be an x squared. Okay, so interpreting what we have there, that's 1x squared minus 1x plus 3 with a remainder of 22. And remember, like, I think the easiest way to write that is just minus 22 over, what we're dividing by, x plus 6. Or you could just say with a remainder of -22. Okay, I think it's written out both ways on the notes. All right, so I said today's lesson was mostly procedural, but now we will see how we can apply some of it, right? So we know that synthetic division that works pretty quickly. Now we'll see kind of how it ties in, right? So wants to know, is x minus 3 a factor of x cubed minus 7x squared plus 11x plus 3? Why or why not? So, before this lesson, the only thing you could really do to check that would be to either try to factor this out and see if that was a factor, or you could go graph this. You could plug it into your graphing calculator and see if it goes through x equals 3, right? Those would be some other ways you could check it. But we can also use synthetic division, okay? Here's what I mean. And you might already kind of guess what we're looking for. So we're going to go 3 into we have 1 for the x cubed minus 7 for the x squared plus 11 for the x, and then 3 for the constant. Okay, so we bring down the 1. That's a 1. 3 times 1, 3. Negative 7 plus 3 would be negative 4. 3 times negative 4, negative 12. 11 take away 12 is negative 1. And then 3 times negative 1 is negative 3. All right, so then you have 3 plus negative 3, or 3 minus 3 is 0, okay? So if we're going to answer this question, is this a factor of this? The only thing we really care about is the denominator, right? So the fact that the denominator is 0 tells me that yes, because it asks us to explain, right? So why do we know? Because the remainder is 0. Something like that, okay? I'll let you try B. And remember, this is not that, it's not the only way you could do it. You could check graphically, which now I wish I would have pulled up my graphing calculator, but maybe you can see what I'm talking about. Okay, so the last application of this is the remainder theorem. So this helps you evaluate a polynomial using synthetic division. Okay, so here's how that works. Well, let's just read the remainder theorem. Okay, so it says if you divide a polynomial p of x by of degree greater than 1 by a linear factor, then the remainder is p of a. Okay, so again, we're looking at the remainder. All right. So in other words, back to what we just did there, since I divided 3 into this, actually we divided x minus 3 into this, then we know x minus 3 is a factor, but we also know p of negative 3 equals 0, right? Because that's a 0. It's a factor. It's also a 0, okay? Which again, kind of going back to algebra 1, that means if we plug in 3 there, there, and there, we should get 0 if we type everything in correctly. All right, so let's look for, see how many are left. I might do one of the two and let you do the other one, okay? So what is p of negative 4? And if I forgot what I was doing, worst comes to worst, I would just remember what that means and go negative 4. Actually, let me talk about that at the end. Let me just do it the right way first. And then we'll talk about what ifs afterwards, okay? So anyways, we're going to use the remainder theorem. That's going to be your best bet, okay? So we're going to divide negative 4 into 1 for x to the 5th minus 3 for x to the 4th minus 28 for x cubed. Notice there's no x squared, right? So there's got to be a placeholder there. That should be a 0. And then 5 for x, and 20 for the last term, okay? And again, just if you're confused, well, how do I know if that's -4 or +4? Remember, when x equals -4, if x equals -4, that goes with the linear factor x plus 4, right? So you got to kind of start to see these two as one and the same. All right, let's go ahead and divide and see how to use this thing, okay? So bring down our 1, multiply, we get -4. Add, we get -7. Multiply again, we get 28. Add again, we get 0. Multiply again, we get 0. Add again, we get 0. Multiply again, we get 0. Add again, we get 5 this time. Multiply again, and we get -20. All right, so in this case, we would have that remainder of 0. Do that in a different color. So all we care about is the remainder. So what we just found out are a few things, really. But the one thing we were looking for is we can say p of -4 is equal to 0. So think about what else that tells me, right? That tells me that if I graph this, it goes to the point -4, 0. It tells me that x plus 4 is a linear factor of this, right? It tells me lots of things. Okay, so anyways, that kind of summarizes everything. There was another. Let's see if there's that third example. Okay, so there are 3. Actually, let me do maybe one other one. I thought there were only 2. So let me just do one of the next 2, and we'll finish up there. All right, so just so you can see it again, and I'll go quick. We're doing 3 and 2, 2, 0, 1, -2, and we're going to look for what the remainder is. Bring down your 2, multiply, you get 6, add, you get 6, multiply again, 18, add, you get 19, multiply, you get 57, and add, you get 55. Let me just make sure that's right. That's not right, so I messed up somewhere. -1. Oh, that's a -1. Okay. So we'll start that again. So we're taking 3 and 2. 2 for the x to the 4th. Don't forget the 0 for the x to the 3. -1 for the x squared. 0 for the x. And -2 for the constant. And then remember, we're just basically looking for what goes there, okay? So we'll go ahead and say p of 3 equals whatever's in the box. All right, that's what we're doing. All right, so bring down your 2, multiply, you get 6, add, you get 6, multiply again, we get 18, add, there you get 17, multiply, you get 57, add, you get 57, multiply again, you get, what do you get, 170, 153, wasn't even close there, 153. And sheesh. All right, so multiply again, you get 51. Add, you get 51. Multiply one last time, you get 153. Obviously, we're going to have a remainder here, and it is 151. So now we know the value of the function where x equals 3 is 151. That's going to be way up there. We'd have to zoom out on our graph to see that, right? So anyways, that's kind of a summary of everything. We can apply this a whole lot for the rest of the chapter. This is one of your more important lessons. So stick with it, and we may do some Q&A on Monday on this. We'll just have to see how you guys seem to be getting it. Let me know what kinds of questions you have. Have a good one.